Welcome back to The Explainer. Today, we're cutting right through the marketing fluff and tackling a core engineering challenge in ELV systems. This is all about the hard data and professional standards you need to truly master your field.
How do you actually pick the right camera for the right space? Well, we're answering that exactly. We're moving way past basic megapixel counts and diving into the hard engineering math. Because slapping a 4K label on a camera doesn't automatically mean it's going to work for your specific project.
Because as the source material points out, quote, get the camera selection right and the rest of the system has a fighting chance. That literally sums up the stakes here. If you get this initial selection wrong, absolutely no NVR or video management system is going to be able to save you later. You've got to build the right foundation.
All right, Section 1, Form Factors and Functions. Let's get right into it.
Let's start by building our tool belt. You've got your bullets. Those are your highly visible outdoor deterrents. Then you have domes, which are perfect for discrete, vandal-resistant indoor needs. Turrets, those are pretty much your modern indoor default right now, mainly because they totally eliminate IR reflection on glass. For big, wide-open spaces, you drop in a fisheye to get a full 360-degree view and basically replace 4 cameras with just one. And finally, ANPRs. These are highly specialized units with super fast shutter speeds built strictly for capturing license plates. Moving on to Section 2, Resolution and Pixel Math. Honestly, this is where we separate the amateurs from the actual engineers. What's super interesting here is how we can take subjective resolution and turn it into a strict, undeniable mathematical formula. We call this pixel per foot, or PPF. Check this out. You need 25 PPF for basic detection, literally just knowing an event is happening somewhere in the area. Bump that to 60 PPF for recognition, which gives you enough detail to recognize someone you've actually seen before. But if you want true identification, like definitively identifying a total stranger, you absolutely must engineer your setup to hit 80 PPF or higher. So here's the absolute crucial takeaway. Resolution by itself is totally meaningless if you aren't calculating your scene size. Think about it. You take a 4-megapixel camera and put it in a 30-foot lobby, right? Boom, you get 60 PPF. That gives you solid recognition. But if you take that exact same 4-megapixel camera and throw it up high over a 100-foot parking lot, your PPF drops drastically down to basic detection. It's the exact same hardware giving you wildly different results based purely on distance. Okay, Section 3, Lenses, Lighting, and Environment. Let's look at the vital decisions we have to make beyond just the sensor itself. Focal length is huge because it dictates your field of view. A 2.8mm lens opens up incredibly wide. We're talking about 110 degrees spread, which is absolutely perfect for swallowing up wide rooms and spacious lobbies. On the flip side, a 12mm lens acts more like a funnel. It gives you a really tight, focused 25-degree view, optimized for looking straight down long corridors or exterior perimeters. Now, if you haven't done the exact math ahead of time, do yourself a favor and specify a varifocal lens so you can dial in the angle precisely once you're out on site. Now, seriously, lock this into your brain. Lighting actually matters more than resolution. Let's say you have a lobby entrance facing the glaring afternoon sun, but your reception desk is sitting right there in the shadows. You need wide dynamic range, or WDR, to handle both the intensely bright and totally dark areas at the exact same time. For spaces like that, you must specify a WDR of 120 decibels or higher, no exceptions. And when we're dealing with the dark, standard built-in IR LEDs will cover you for about 30 to 50 meters out, but you absolutely need to make sure you specify Smart IR. Smart IR automatically adjusts the infrared intensity based on how close an object is. This is a game changer because it stops a person's face from turning into a washed-out glowing white blob when they walk right up to the lens. To make sure your hardware actually survives its environment, you've got to check the ratings. IP66 means the camera is completely dust-tight and can survive powerful water jets. That rating is mandatory for all external cameras. Then there's IK10, which means the camera is impact protected against 20 joules of force. IK10 is literally mandatory for any camera mounted low enough to be reachable by hand, or, reachable by a frustrated vandal. All right, Section 4 is our masterclass case study. Let's see how this all comes together when we apply these exact engineering specs to a complex, 5-star hotel environment. Starting right in the lobby, we've got a total nightmare scenario.
complex chandelier lighting overhead, intense sun glare coming in from the main glass doors, and deep shaded corners all happening simultaneously. The proper engineering solution here is deploying an 8-megapixel turret camera equipped with 120 decibel WDR to handle all three of those lighting challenges flawlessly. Moving down into the hallways, standard 4-megapixel domes with 4mm lenses will work absolutely perfectly for your guest corridors. But compare that with the back of house corridors. You'd still use a 4-megapixel dome back there, but it must be heavy-duty and IK10 rated. Why? Because service staff and massive catering trolleys are inevitably going to smash into them at some point. Out at the parking entry and exit gates, we strictly divide the labor. We drop in 2 dedicated 2-megapixel ANPR cameras that are focused solely on grabbing those license plates. Then we pair those up with 1 standard 4-megapixel overview camera for each lane, just so we can capture the broader context of the entire scene. To wrap up the hotel, the outer perimeter naturally demands rugged 4-megapixel bullet cameras. These need to feature both IP66 and IK10 ratings, have 30-meter built-in IR, and they have to be mathematically spaced to maintain that crucial 25 PPF detection coverage we talked about earlier. Meanwhile, over on the pool deck, we deploy a 4-megapixel turret, but it absolutely requires a specialized sealed housing to protect the delicate electronics against all that ambient humidity and chlorine in the air. Let's wrap this up with Section 5, the 3 golden rules. We're going to distill all of this camera selection logic into 3 uncompromising directives for your next project. If you take absolutely nothing else away from this explainer, remember these 3 rules. Rule number 1, always calculate your required pixel per foot based on your specific use case before you even glance at a camera's megapixel specs. Size the camera to the scene. Rule number 2, mandate WDR over 120 decibels at every single entrance. Rule number 3, secure all of your outdoor hardware with both IP66 and IK10 environmental ratings without exception. You now have the rock-solid foundation you need to engineer a perfect layout, but ask yourself right now, is your current security system actually engineered to identify threats, or was it just built to record blurry shapes? Think about it. We've solved the hardware piece today, but in our next explainer, we're going to tackle compression codecs like H.264 and H.265+. We're going to show you exactly why your storage bill is about to be cut right in half. Keep learning, and we'll see you in the next one.